Hello students, today's lecture we are starting the second unit, that is the stereochemistry first. The stereochemistry is the most important concept to study the reactions and its products. What possible products will form when different types of isomers are present, because in some reactions some isomers show the specific type of reactions, some isomers show the same types of specific product. That's why stereochemistry is important. Stereochemistry again identify the molecules, means if any molecule is either optically active or inactive, which can be easily identified by applying the various concepts regarding the stereochemistry. If any molecules having the any angle of symmetry, plane of symmetry or axis of symmetry, then at that time we can say that that particular molecule is not optically active. Means that theory shows us that whether any compound is optically active means it cannot contain any angle of symmetry or any type of symmetry angle. So this concept is very useful to identify the molecules, optically active molecule, optically inactive molecules. Chirality is also important concepts. In the chirality, we understand the chiral molecules are those molecules which having the four different groups attached on the same atoms. But the chiral molecule can be identified as a chiral. Atom can be identified as a chiral by four different groups, but molecule can be identified by its structures. The molecule can be represented by two configurations. One is the mirror images of each other, that is enantiomer, and other is the non-superimposable. It is also considered as enantiomer. Example: mesotartaric acid, biphenyl and alene. Mesotartaric acid, biphenyl and alene. Mesotartaric acid is obtained optically inactive compound. Mesotartaric acid is optically inactive compound under certain conditions. Some compounds do not contain any chiral center, but they are optically active. Example: biphenyl compounds, alene compounds. There is no sufficient condition for optical inactive, that is, it may contain the chiral carbons. The main criteria of optical activity is that the molecule as a whole must contain chiral centers. Means that we can define the molecule chirality as the chirality of the molecules can be defined by the whether the molecule is superimposable on its mirror images, and if the molecule and its mirror images are non-superimposable, then the molecule is chiral or dissymmetric. Next important criteria is the element of symmetry. There are three different elements of symmetry. One is the plane of symmetry, second is the axis of symmetry, and third is the invergence of symmetry. Plane of symmetry means if you cut the molecules and these molecules divided into two same and identical halves, at that time we can say that this is the plane of symmetry. The plane of symmetry is an imaginary plane that passes through the molecule such that the atoms or groups on one side of plane from mirror images of those on other sides. It is useful. It is contain two or more chiral centers. OH, OH, double OH. Second, tartaric acid, mesotartaric acid, pair of the meso compound shows the plane of symmetry, and pair of enantiomer does not show the plane of symmetry. Center of symmetry. Center of symmetry is defined as a point the molecule for which the line drawn on one side on the produce to equal distance on opposite side meet exactly similar points. Here is the example. We can understand this example easily by looking this CS3 exactly opposite to this CS3. This H exactly opposite to this H. This COH exactly opposite to this COH. This H exactly opposite to this H means these are the center of symmetry. Next one is the alternating axis of symmetry. In the alternating axis of symmetry, molecule is said to be possess for alternate axis of symmetry of n rotated through the angle of 360 degree. About this is axis and followed by the reflection of the resulting molecule in a plane. Enantiomer to produce an axis, then the mirror images is then the molecules that is called as the rotational reflection axis. These are the example of this rotation reflection axis. Original molecule in a is the molecule is obtain different rotation through the mirror planes. Mirror then is a plane to be the AB performed above the first projection with structure. Therefore, the molecule is said to be possess the four-fold alternating axis of symmetry. In the next lecture, we will discuss the stereochemistry of humidine. Thank you.